7. Which situation describes an object that has no unbalanced force acting on it? So this question is asking you which no unbalanced force. So no net force, right? This is like Newton's second law, F equals ma. So if there's a net force, sometimes we write F net, then that means that it's unbalanced. So that object, if there's a net force on it, is going to accelerate. So another way of asking the same question, or rephrasing this question, is in which of these situations is the object not accelerating? Because if it's accelerating, the only thing that could possibly be causing it to accelerate is that there's a net force on it. There's an unbalanced force acting on it. So let's go through one by one and see which ones are accelerating and try to find the one that's not. Okay, the apple in free fall, definitely accelerating, right? You have the earth, you have a tree, apple falls from the tree. It's accelerating toward the ground. It's going faster and faster until it hits the ground. So that is most certainly accelerating. There must be an unbalanced force, and there is. It's gravity, right? That's the unbalanced force that's acting on it. How about a satellite orbiting the Earth? It could be moving at a constant velocity, right? Oh, I shouldn't say that. At a constant speed. Speed is a scalar, so it could be going around and around at the same speed, but its velocity is changing because its direction is changing. Like at this particular moment, its velocity is in this direction, but at some moment in the future it's going to be over here, and now its velocity is going to be in this direction. It's always moving tangential to its path, to its circular path. So the acceleration is towards the center of the Earth, and this is centripetal motion. Basically, the acceleration serves only to change the direction, and the velocity changes the direction, but the speed doesn't change. Long story short, it is most certainly accelerating. So that one is out as well. A hockey puck moving at constant velocity across the ice. That's not accelerating. It's right there. It's constant velocity. So if the velocity isn't changing, that means both the magnitude and the direction, because velocity is a vector, are not changing. So if the velocity isn't changing, then it's not accelerating. There's no unbalanced force on it. The 3 is the answer. And just for completeness, 4, a laboratory cart moving down a frictionless 30-degree incline. So suppose you had an incline like this, and that's 30 degrees, and it's frictionless. So now you got this cart that's going down. It's going to keep going faster and faster. So even though it's not moving straight down toward the Earth, it is going faster and faster down the incline. And that represents acceleration. That would only happen if there was an unbalanced force. So there's definitely an F net. 3 is the best choice.